In this video, we'll be discussing L'Hopital's rule. L'Hopital's rule essentially states that the limit as x goes to c of f of x divided by g of x is equal to the limit as x goes to c of f prime of x divided by g prime of x. This rule can only be used when you have the indeterminate form, so 0 over 0, or infinity over infinity, or negative infinity over negative infinity. In L'Hopital's rule, both functions f and g have to be differentiable on the open interval from a to b, except when x is c, it is not differentiable, and g prime of c cannot be equal to 0 for all x's within that given interval. So an example where L'Hopital's rule can be applied is this particular function. So the limit as x goes to 0 of e to the 2x minus 1 divided by x, we can set numerator equal to the limit of x going to 0 of e to the 2x minus 1, the denominator equal to the limit of x going to 0 of just x. So we define these functions as f of x equaling e to the 2x minus 1 and g of x just equaling x, so as we just stated. And we take the derivative of the numerator and the denominator, and we get this function, 2e to the 2x divided by 1. And when we substitute in that value c, 0, we get 2 over 1. So here we determine that the limit of x going to 0 of e to the 2x minus 1 divided by x is just 2. So another example where we can use L'Hopital's rule is when we have infinity divided by infinity as an indeterminate form. So another great example would be the limit of x going to infinity of ln of x divided by x. As ln of x, the numerator, goes to infinity, we go to infinity. The value of x approaches infinity. And as the value of x in the denominator goes to infinity, it approaches infinity. So we get that indeterminate form. So how we apply the L'Hopital's rule is we take the derivative of the top and the bottom separately. So we set f of x equal to ln x and g of x equal to x. And we take the derivative of f of x, so f prime x divided by g prime of x, and we get 1 over x over 1, which just simplifies to 1 over x. And so when we plug back in the value c, infinity, so as it goes to infinity, we get 1 over infinity, which is 0 because the denominator is getting smaller and smaller and smaller the bigger it gets, this whole fraction. So we plug back in c, we plug in infinity for c, and we get this equaling to 0, the limit, because the denominator is getting smaller and smaller and smaller, which is basically dividing by 1 by infinity, which equals out to 0. So an example where L'Hopital's rule cannot be applied is this particular function where we have the limit as x equals to 0 of sine of x divided by x squared minus 5. So we put in x and we get 0 divided by negative 5. Most people will think, oh, we have 0 in the numerator, so L'Hopital's rule can be applied. But this is actually false because there's no indeterminate form. The indeterminate form has to be 0 over 0, infinity over infinity, or negative infinity over negative infinity. And that's not the case here because we have a different number other than 0 in the denominator. So in this particular function, we determined that when you plug in 0, you get 0 over negative 5, which can't be used for L'Hopital's rule, like we stated. And so the limit is just 0. That's it. L'Hopital's rule squared. In this example, the limit as x goes to 0 of 2 sine x minus sine 2x divided by x minus sine of x. When we plug in 0 for x, we get 2 times 0, so that's 0, minus sine of 0, which is 0,
divided by 0 minus 0. So this gives us the indeterminate form, 0 divided by 0, meaning that we can apply L'Hopital's rule. So we take the derivative of the numerator and we take the derivative of the denominator. So the derivative of the numerator is 2 cosine x minus 2 cosine of 2x, and the derivative of the denominator is 1 minus cosine x. So the limit as x goes to 0 of this, we plug in 0 for x. So cosine of 0 is 1, so 2 times 1 is 2, minus 0 times 2, the cosine of 0 is 1, so 2. 1 minus 1, we still get that indeterminate form, 0, 0. Now this doesn't necessarily mean that 0 is going to be the limit, the value of the limit. It just means that we can apply L'Hopital's rule again. So we take the derivative again, we get negative 2 sine x minus 4 sine 2x. This is actually addition because the derivative of cosine is negative sine, crosses out the negative, and the derivative of 1, 0, derivative of cosine is negative sine, so it crosses out that negative, so we just get sine of x. So the limit as x goes to 0 of this, we plug in 0 in for x, the sine of 0 is equal to 0, plus the sine of 0 is equal to 0, so 4, 0. The sine of 0 is equal to 0, so this gives us indeterminate again. So we get it. We've got the indeterminate 3 times now, so we should try taking the derivative again. So the derivative of the second derivative would be negative 2 cosine of x plus 8 cosine of 2x. That's divided by cosine of x. So we have negative 2 cosine x plus 8 cosine 2x divided by cosine x, and when we substitute in x, we get 1 negative 2 plus 8 divided by 1, which gives you 6 over 1. So the value of this limit of this function is just equal to 6.